All right, in part B of section 1, we're going to look at significance tests for slope. So what is the standardized test statistic for the significance test of a slope? Is it on the formula sheet, and what degrees of freedom do you use? Well, we're going to use this as our null hypothesis, basically that beta equals whatever the null value is, all right? And that's the hypothesized slope. 95% of the time, almost probably 99% of the time in AP Stats, this is going to be 0, indicating there's no relationship between the two variables. Now, we're going to use T as our standardized test statistic. Notice it's B minus beta, our null value, divided by the standard error of B, right from our table. Degrees of freedom is still n minus 2 because we're dealing with slope and y-intercept. And just like with any hypothesis test, it could be left-tailed, right-tailed, or two-tailed. All right? So keep those in mind. Nothing's changed here. And there's your test statistic. This is the way it shows up on the chart. We just put in the correct values for what we're doing. So this would be T, little b, minus beta over the standard error of little b. All right, so do customers stay longer at buffets give larger tips? Charlotte, an AP Stats student who worked at an Asian buffet, decided to investigate the question for her second semester project. While she was doing her job as a hostess, she obtained a random sample of receipts, which included the length of time in minutes the party was at the restaurant and the amount of tip in dollars. Do these data provide convincing evidence that customers who stay give larger tips? So here's a scatter plot of the data with the least square regression line added. Describe what the graph tells you about the relationship. Just raw data. What does it tell us? So this is a hint that we're using DOFs to describe our scatter plot. So I'd say there's a weak, positive, linear association, it's not curved, between the time spent at a buffet and the tip given. And there's no apparent outliers. So we've taken that data and here's the output. B says, what's the equation of the least square regression line for predicting the amount of tip from the length of stay? Define any variables. Well, okay, so y hat is our predicted tip, and x is the length of stay in minutes, right? So I'm going to use my table, and I'm going to find my slope right here, and my y-intercept right here. And this is the equational line the table is giving me. I've defined the variables, and I've used appropriate y hat here, so we're good to go. Part C says interpret the slope and the y-intercept of the regression line in context. So my slope is 0.303013. Remember what my x variable is, it's minutes. So for each additional minute at the buffet, the predicted tip increases by 3 cents. So for y-intercept, that's when x is 0. That means 0 minutes. So if a party doesn't stay at the buffet at all, which is 0 minutes, the predicted tip is $4.54. But you and I know that really doesn't make sense. Sometimes that happens when they ask you to interpret y-intercept, but just make a statement that it doesn't realistically make sense if that's true. Part D, carry out an appropriate test to answer Charlotte's question. Is there a relationship between the time spent and the tip given? So it gives you all this output. So we're going to do a hypothesis test. So we start with our hypothesis. So in our state step, we'd say the null is that beta is equal to 0 versus that beta is greater than 0. Because we say greater than 0 because we think that the more time they spend at the buffet, the higher the tip. That would mean a positive association, so we would show it in this way, greater than 0. And then we define what is beta. It's the true slope of the regression line relating length of stay to the tip amount. And we're going to test with an alpha of 0.05. Okay, I'm going to walk you through the plan step. We're going to perform a t-test for slope if our conditions are met. Now this is the long version, but this is the outputs you need, and notice it was given to us. So first, linear. The scatter plot is weak, positive, and linear. Shows no leftover pattern in the residual plot. All right, so here's our residual plot. We can see that there's really no pattern here, so we're good to go to assume it's linear enough. Independence. Knowing the tip amount from one party won't inform us about another party's tip. And 12 is less than 10% of all the receipts from the buffet. I hope so. So that's L-I. N is for normal. We look at the histogram of the residuals. Okay, and there's no strong skewness, there's no outliers, so we can assume approximate normality of these guys. E is for equal standard deviation. So we go back to our residual plot, make sure that the scatter is pretty equal above and below the line. It's fairly equal. Scatters around residuals equal 0 line, that's this line right here. So that's all I really have to say. It's just referencing our residual plot. And then remember the A is just for and the R is for randomness. Were receipts randomly selected? Yes, they were. Again, just remember, a lot of times, if they ask you to do a hypothesis test on slope, they will make a statement like, assume all the conditions are met, so you do not have to spend time doing this. But you do need to kind of have an idea of what's going on. All right, on the do step, actually I'm going to show you how this table gives you everything you need. So this value right here under T, and in the row with the slope, that's what you need because we're looking at slope. This is the T statistic, and this is the p-value. Now there's a caveat on this, I'll show you in a moment. But from our table, we know that T is 1.23. Our degrees of freedom, remember it's a sample of 12, we have to subtract 2, so degrees of freedom is 10. Always want to show what T statistic is, what is degrees of freedom. And I just remember that in our alternative hypothesis, we said that beta was greater than 0, so it's a right-tailed test, right? Now, there is a p-value here, but the problem is, anytime it's an output, the p-value always assumes it's a two-sided test, so it's both tails together. So if in the event, like this question, we only have a one-tailed test, we take this p-value and divide it by 2. And this is our true p-value for this test. All right, sometimes you have to do this step, sometimes you don't. It just depends on the alternative. Now, from here, there's my p-value, I can draw my conclusion. So because 0.124 is greater than 0.05, we fail to reject the null. We do not have convincing evidence that parties who stay longer at the buffet leave larger tips. That's all there is to it. And then lastly, can you use the calculator to find this test for slope? Of course you can, yes. So again, you have to input the data into list 1, list 2, explanatory list 1, response list 2. Then you're going to go stat test, and we're looking for test F. It's linear regression t-test. And when you press this, it's going to run the linear regression line, it's going to run the t-test, it's going to do all the things for you all at once. So you got to make sure it's picking the right list for your explanatory and response variables. And it's assuming 0, right? And you got to pick the right inequality like you would with the hypothesis test. And then you hit calculate. So here's my t statistic. Here's my p-value. Notice it's what we did when we divided by 2. Degrees of freedom. If we needed the regression line, it gives you the y-intercept, the slope, and then the standard error of the slope right there. Everything is in the output that you could need. So it makes the test run really quickly, actually.